Hey everyone, I'm a technician at Etisalat, and in Dubai, this might actually be my last project in Etisalat. I wish I could have recorded my previous projects as well, as they were really interesting. Today we're going to patch free one FDH code is OGH-1170. It located in Dubai, Al Qusais. We are here to upgrade, because most of patch cords are dead, old and messy also. It's been experiencing a lot of issues recently. So, let's go to the work. First we met with security and got permission to start. Then we moved on to our work. This building is actually divided into two parts, and it has two separate FDHs installed. But today, we're only focusing on converting one of them to a patch-free. The building has a total of 4 levels, ground plus 3 floors. The FDH we're working on is located on the ground floor, and each floor has its own IDF. Our main goal is to complete this conversion without disrupting the residents we're working at night to minimize the impact on the customers. Most people are asleep during these hours, so any temporary loss of connectivity should go unnoticed. Plus, Etisalat has already informed the building management about our work schedule. The first step is observation and data collection. We need to assess the current condition of the FDH and IDF and estimate how much time it will take to complete the project. First, we'll visit the FDH and IDF to inspect their state and check how everything is functioning. We'll splice the active ports and remove any unnecessary patching to ensure that ports remain available for future connections. To collect data from the FDH, we call our controllers, who have full access to the system. They monitor the entire FDH, checking which splitters have active connections and which ones are down. We'll remove each patch one by one, while the controller checks their system to tell us which connections are active and which ones are free to remove.
21 check. Same port. 21 same port. 21 55. Okay, 22 check.
In the next step, we'll trace the active ports from the FDH to the IDF and remove any unnecessary patching on the IDF side. To do this, we'll pass light through each splitter one by one. Then on the IDF side, we'll separate the cables splitter by splitter. We'll also separate the multi-core cable colors accordingly, making sure everything is well organized. This way, when we start splicing at the FDH, we won't need to trace the connections again, ensuring a smooth process without disturbing the customers. Now, we move on to the PatchFree Conversion, which is the most critical part of the process. We'll start with the first IDF, then proceed to the second and third IDFs, and finally we'll complete the FDH PatchFree Conversion. We've already finished splicing the first IDF, and now we're about to tackle the second one. The cables and multi-core fibers we organized by splitters earlier will now be spliced together. This pre-organization helps us save a lot of time and reduces the risk of errors during the conversion. Fiber optics are amazing because they transmit data as light signals, traveling at nearly the speed of light. Each fiber strand is thinner than a human hair, yet it can carry massive amounts of data over long distances with minimal loss. This makes fiber optics one of the fastest and most efficient ways to connect buildings and homes to high-speed internet. There are fewer connections here at the second IDF, so we'll make a few adjustments and splice directly within the IDF. The cables are a little short, which means we'll have to splice while standing, something that can be tricky but manageable with the right setup. We're removing old patching and unnecessary materials to streamline the system. Once that's done, We'll install the splice tray in the middle, adjusting the cable lengths carefully to ensure everything is neat and ready for future use. Splicing fiber optic cables requires precision. We align the glass cores perfectly to avoid any loss of signal strength, which could cause data interruptions. Once everything is spliced and connected, we'll test the connections to ensure that the system is working at optimal efficiency. Today marks the 4th day of working on this FDH, and now we're ready to make the main FDH patch-free. All 3 IDFs have already been converted to patch-free, so now we'll trace and separate the drop fibers coming from the ground floor to the FDH, splitter by splitter. We'll also trace the main cable, making sure to identify which fiber is spliced with which splitter. One by one, we'll remove the patch panels and splitters, and eventually, the wall mount itself will be taken down. It's a detailed process, but each step gets us closer to a cleaner, more efficient setup. After tracing, we'll prepare the cables coming from the IDF, as well as the main cable. Once they're ready, we'll start by splicing the IDF cables with the splitters, following the color coding we noted earlier. Then we'll move on to splicing the main cable. We'll save the drop fibers for last, so everything goes smoothly. Personally, I enjoy working on the FDH more than the IDF. Here the cables are longer, giving us more room to work. We can sit comfortably while we splice, and it's less physically tiring. While dressing the cables, some of them turned out to be too short, so we had to shift the FDH slightly higher and adjust a few cables to make them fit better. Once the splicing is done, we'll hang the FDH back in place, dress the cables properly, and label everything for future reference. It's important to leave the setup as organized as possible for any future maintenance. And that's how we completed the PatchFree conversion on this FDH. I hope you enjoyed the video. If you have any suggestions or ideas, feel free to leave them in the comments. And don't forget to like the video if you found it helpful. Thank you for watching.